Everyone, good morning. So, good morning. This is lecture number 10 of vector analysis, and this is the last lecture on surface and volume integral, right? So we have already finished one topic, which is gradient, divergence, and curl, and we have also conducted a test on that topic. The next topic that we're going to complete today is line integral, surface integral, and volume integral. So, surface integral in the previous class we have solved 4 problems on surface integral. We will do another four problems on surface integral in this class, and then volume integral I'm going to do only one problem on volume integral, right? Because when we are doing problems based on a Gauss divergence theorem, there we will do lots of problems based on evaluating volume integral. But as of now, in volume integral I'm going to do only one problem, right? Okay. So far what we did is we have finished gradient, divergence, and curl. That is one topic. And the second topic that we're going to finish today is line integral, surface integral, volume integral, right? So soon we will have a test on this topic, maybe on Sunday or Monday, right? I'll give you some time to practice on that. Now, in the next class onwards, we're going to move on to the core topic of vector analysis. That is, we are going to see 3 theorems: Gauss divergence theorem, Stokes theorem, Green's theorem. So we will take each theorem. We will solve many problems on each theorem, right? After finishing those 3 theorems, almost 90% is completed. Only one topic is left, which is curves, curvature, Darcy, and Seret-Ferner formula, right? Okay, super. So if you haven't watched the previous class on surface integral, go through that, because this is the continuation of the previous class. So I just we will just recall what we did in the previous class, right? This is the previous class notes. So what we did is we have defined what is surface integral. Last class, last problem, we have solved, right? Oh, we need to start with, okay. Okay, we will start with that problem, right? We will start with the problem. Is it that problem? Evaluate. I'll just tell the problem. You just say. I actually forgot that problem. I'll just tell the question. You say whether it is that problem or not. So evaluate double integral over S f vector dot n cap ds, where f is 18z I vector minus 12j vector plus 3y k vector, and S is the part of the plane 2x plus 3y plus 6z is equal to 12, which is in the first octant. Is this the problem? Yes, okay, sure. We'll start with that problem. Okay. So in the previous class, what we did is, so we have defined the surface integral, and this is very important. So we need to find ds according to the problem. So ds is projection on, it can be projection on xy plane or yz plane or zx plane. You need to choose accordingly. And we have solved the first problem. Evaluate double integral over s f vector dot n cap ds, where f is this and s is the part of the surface. So formula is double integral over s f vector dot n cap ds. So what is n cap? So n cap is del phi by modulus of del phi, where phi is the surface that they are giving, right? So here phi is x square plus y square plus z square minus 1 is equal to 0. So I'm finding n cap, which it turns out to be xi plus yj plus zk. So we need f vector dot n cap. So if you make a dot product with f with n cap, so we will have xyz plus xyz plus xyz, which is 3xyz. Now you need to choose ds. So I'm using ds to be projection on xy plane. So that means it will be dx dy divided by n cap a. So you find the n cap k, and then you evaluate, find the limits that we have discussed in the previous class, how to do that, right? So you just go through that, right? So in xy plane, z is 0. So z will be 0. So we have x square plus y square is equal to 1. And x varies from 0 to root of 1 minus x square. And y varies from 0 to 1, right? I have already explained how these all came. And second problem is evaluate double integral over s f vector dot n cap ds, where f is this and s is the surface of cylinder in the first octant. I have said that since they are given z limit, you take projection to be dy dz or dx dy dz by n cap I, or dx dz divided by n cap j, modulus of n cap j, right? So I have already explained how to take this in the previous class. And third problem is S is the surface of the plane 2x plus y is equal to 6 in the first octant. cut off by the plane z is equal to 4, right? So we'll start with the fourth problem. So we'll start with the fourth problem. So evaluate double integral over s f vector dot n cap ds, where f is 18z I vector minus 12j vector plus 3yk vector, and s is the part of the plane. S is the part of the plane 2x plus 3y plus 6z is equal to 12, which is in the first half. Which is in the first half, right? So we'll do this problem. So I'll do this quickly because you all know how to do this problem, right? Okay. So first, what is P here? So here the surface is 2x plus 3y plus 6z minus 12, right? So we will find n cap. So n cap is del phi divided by modulus of del phi. Now what is del phi? So del phi is dou phi by dou x I vector plus dou phi by dou y j vector plus dou phi by dou z k vector. So dou phi by dou x will be 2i. So 2i vector, dou phi by dou y will be 3. So 3j vector, dou phi by dou z is 6. So it will be 6k vector. So 2i plus 3j plus 6k is our del phi. So this will be 2i plus 3j plus 6k divided by root of modulus of del phi will be 4 plus 9 plus 36. So this will be 2i vector plus 3j vector plus 6k vector divided by 7, right? So it will be root 49. Root 49 is 7. Now what will be our f vector dot n cap? F vector dot n cap. So f vector is 18 z I vector minus 12 into j vector plus 3y into k vector dot, so 2y plus 3j plus 6k divided by 7, right? So make a dot product, so I can take this 1 by 7 outside. So 18 z into 2, so it will be 36 z minus 12 into 3, so it will be minus 36. 3y into 6 will be 18y. So this will be 1 by 7. So 18y 36 z minus 36 plus 18y. We can let us keep this as it is, right? So it is in terms of z and y. Okay. Cannot take anything common, right? Or else we can also take 18 common here. So if we take 18 common, okay. So let us keep this as it is, right? Okay. Now what we'll do is we need to choose ds, right? So let us choose ds to be you can choose anything here, right? So I'm choosing on xy plane, so it will be dx dy divided by modulus of n cap dot k vector. Here you can choose anything, right? So if you are choosing dx dy means your integral everything that is your f vector dot n cap has to be in terms of xy. I have already said in the previous class, right? Okay, I'll repeat. It will be n cap dot k vector, right? N cap dot k vector. So what will be n cap dot k? This is your n cap, and make a dot product with k. Make a dot product with k. You will have what? 6 by 7, right? So this will be 6 by 7. So this will be 7 by 6 dx dy. 7 by 6 dx dy is your ds, right? So 7 by 6 dx dy is your ds. So therefore, double integral over s f vector dot n cap ds is equal to double integral over r. Now what is f vector dot n cap? So it is 1 by 7 36 z minus 36 plus 18y. This is for f vector dot n cap. And what is ds? ds is 7 by 6 dx dy, right? Now remember, we need to integrate with respect to dx dy, but we should not have z here, right? So everything should be in terms of xy. So we need to convert z in terms of xy, right? Z in terms of, we need to convert z in terms of xy, and we can easily do, right? Because we know the surface is 2x plus 3y plus 6z is equal to 12. So 6z is equal to 12 minus 2x minus 3y. So z is 12 minus 2x minus 3y divided by 6, right? So we will put z here. So this will be 1 by 7, 36 into, so z is 12 minus 2x minus 3y divided by 6 minus 36 plus 18y, right? So I'll just simplify this. I'll just simplify this alone, right? I'll just simplify this alone. This alone we will simplify, right? Because these two are constants. So this will be 6 are 36. So we will have 6 times this. So 6 12s are, it will be 72. 6 into minus 2, minus 2x is minus 12x. This will be minus 18y. Here you will have minus 36 plus 18y, right? So this will get cancelled. And 72 minus 36. 72 minus 36 is 36, right? So it will be 36 minus 36 minus 12x. So no, 72 minus 72 minus 36 is 36. 36 minus 12x. So therefore, in place of all these, we can write 36 minus 12x. Now we can see we have converted z in terms of xy, and overall when we simplify, we have only in terms of xy only. Now we need to find limits also, that we will do now. So this will be double integral over r. So already we have 1 by 7. So this will be 36 minus 12x, and already we have 7 by 6 into dx dy. This 7 will get cancelled. And if I take the 6 outside here, so we have double integral over r, 6 minus 2x, and we have this 1 by 6 dx dy. Again, this 6 will get cancelled. So we have double integral over r, 6 minus 2x dx dy. Now we need to find x limits and y limits, right? Very easy that you can do. And how to find limits? So we are in xy plane, so z will be 0. So what is the plane here? So 2x plus 3y plus 6z is equal to 12. So we are in xy plane. This is a projection on xy plane, right? So that means z is 0. Z is 0. We will have 2x plus 3y is equal to 12, right? 2x plus 3y is equal to 12. This is the now we need to find x and y limit, right? So you can do like, you put y to be equal to, if you put x to be equal to 0, you keep one as variable, other as numbers, right? I said in the previous class. If x is 0, what will be y? Y will be 4, right? That is, if x is 0, y will be 4. Now other you treat as a function, that is x. Sorry. Yes, if x is 0, y is 4. That means y varies from 0 to 4, right? Because we are in first octant. So in first octant, x, y, z all are positive. So if x is 0, y will be 4. That means y varies from 0 to 4. So we have found y limits. Now what about x? So now you treat x. What about x? So 2x is equal to 12 minus 3y. So x will be 12 minus 3y by 2. That means x varies from 0 to 12 minus 3y by 2, right? X varies from 0 to, because we are in first octant, it starts with 0. So x varies from 0 to 12 minus 3y by 2. Or you can put y to be equal to 0. You will have x to be equal to 6. You can also have like x varies from 0 to 6. And you treat 3y is equal to 12 minus 2x. You can also do like that, right? So if I'm putting x to be equal to 0, that is I'm finding y in terms of number. That is 0 to 4, 0 to 6. That is I'm finding y in terms of number. You can also find x in terms of number, and you can treat y in terms of variable. That is, we need to cover the entire region, right? If you take both as number, we can cover only this line and this line, but we need to cover this portion also. For that, we need to we can only keep one as number, other we need to treat as variable. Then only we can cover all these, right? That is the idea. Therefore, is it clear? The limits is clear. So in this, just if you have seen the previous class, then these are very easy, right? Therefore, this will be so dy. So y varies from 0 to 4. X varies from 0 to 12 minus 3y by 2, 6 minus 2x dx dy. Now it is easy to evaluate, right? And then you can do from now on. This will be integration of 0 to 4, and this will be 6x minus 2x dx is 2x square by 2, 2x square by 2. So 0 to 12 minus 3y divided by 2 into dy, right? Into dy. So I think there is some noise going outside, so please adjust with that. Okay. So we will put upper limit. So 12 minus 3y by 2 into x square. Can do now, right? So we need to just integrate 6 times 12 minus 3y by 2 minus 12 minus 3y by 2 whole square dy, right? I think I can do this. Can I just tell the answer? So this will be 2 1s are 2 3s are. This will be integration of 0 to 4. 36 minus 9y minus this will be 1 by 4 a square plus b square. Right, you just integrate this, right? So I don't know why I'm getting lots of disturbance. So we'll get answer to be equal 24, right? So we'll get answer to be equal 24, right? So we just have to integrate this, very easy. So just a minus b whole square formula, a square plus b square minus 2ab. Simplify this, integrate with respect to dy. You will get 24 as the answer, right? You will get 24 as the answer. So can you move on to the next problem? Kiran Kumar, is it clear now? So now we'll move on to next problem, that is fifth problem. So this is very different problem, right? You just have to listen very carefully. So the problem that we want to solve is evaluate double integral over s f vector dot n cap ds, where f is given by x cube minus yz I vector minus 2x square y j vector plus 2k vector. S is the surface and S is the surface bounded by x is equal to 0, y is equal to 0, z is equal to 0, x is equal to a, y is equal to a, z is equal to a, right? So what is this? This is nothing but a cube, right? So we need to evaluate this over a cube. Very, very different problem. So in the previous all four problems, they are given an equation, right? So S will be something a equation. Yes or no? So it will be like x square plus y square plus z square is equal to 1. Here it is 2x plus 3y plus 6z is equal to 12. So I can see here phi is del phi. So we have usually written n cap to be del phi by modulus of del phi, right? So soon I'll get some good mic so that the noise will be reduced, right? So I think this mic is getting lots of noise for you, right? So we need in the previous all previous problem they are given the surface directly, but here they are given the cube, right? So this is very tricky problem. We have to listen very, very carefully, right? So how to evaluate this surface integral when they are given the surface to be equal to cube? This is a cube, right? Okay, so we will do that. So they are given the surface to be equal to cube. So what we will do is, so first we will draw the diagram, right? Can you talk in English? I don't know Hindi. Sorry. Now here the surface is this these lines. So these lines, the surface is not including this portion. It only includes these lines bounded by these lines, right? Okay. Let us call this as x-axis, y-axis, z-axis, right? This is our x-axis, y-axis, and z-axis. Now let us this is our origin, right? This is our origin. Now we will mark the vertices, right? Let us call this as A, call this as B. Very, very important problem, right? Because these are the problems that we will use in Gauss divergence theorem also. So listen this, if you listen this first one problem, then you can do any problem, right? So A, B, C, this is D, this is E, F, G, E, F, G. So how many surfaces here? There are 6 faces, right? The 6 faces are the 6 surfaces here. So what we'll do is for each surface, we need to find n cap, right? So how you usually find n cap? So n cap is del phi by modulus of del phi, right? So here we don't know n cap. So for each surface, we will have n cap. That is for there are 6 surfaces here, right? 6 faces. Front, back, right, left, up, down. So there are 6 faces here. So for each 6 faces, you need to find n cap, right? So for each 6 faces, you need to integrate separately. You need to add up all this to get the surface integral, right? Okay. So I'll do one by one, right? So what we'll do is first we'll draw I'll draw table, then I will explain. So this table is very important. So first you need to remember these headings, right? This is phase. So equation, phase equation, outward normal, that is your n cap. That is your n cap, and you just find f vector dot n cap, and what is your ds. So ds can be dx dy by n cap I, or can be dy dz by n cap j, or dz dx by n cap. You know all these, right? So what I'm going to do is, let us take the first phase, right? So there are 6 phases: S1, S2, S3, S4, S5, S6, right? So just take the front face. So what is the front face? So front, back, left, right, left, up, down. You need to go in this order, right? Okay. So what is the front face here? A, B, E, F, right? A, B, E, F is your front face. A, B, E, F. Now, what is the equation of this front face is? So you just see this is the front face, right? So this is the front face. Now you can see this is bounded by what? X is A. This is X is equal to A. This y is equal to this distance is B, right? This distance will be A, and this will be Z. Sorry, this will be C, right? Okay. Now you can see that this plane, you just only see this rectangle, right? This plane is in what? Perpendicular to this x, perpendicular to this x plane, perpendicular to x plane at a distance of A. So this is nothing but x is equal to A, right? Is it clear? So you can see this A, B, E, F. It is a front face which is perpendicular to this x plane, and it is a distance of A. So that means it will be x is equal to A, right? So for all the cubes, right? For all the any problem you get, this equation and n cap will not going to change, right? These are fixed. So depending upon the f they are giving the question, this m dot n will change, but these 3 column will not change for any problem if you have a problem that is based on cubes, right? Okay. So instead of x is equal to A, y is equal to Z is equal to A, suppose if they give x is equal to 2, y is equal to 3, Z is equal to 4, then here we will have x is equal to 2 is the equation of this plane, right? Okay. So and similarly we have finished front now, right? Now you see the back face. So what is the back face? This is the back face, right? This is the back face, which is OCDG, right? Which is OCDG. So OCDG. So OCDG is your back face. So what is the equation of this back face? So this plane lies on YZ plane. Yes or no? So you just see the back side. It lies on YZ plane. That means what? X is 0. Right? X is 0. This is OCDG. OCDG. Is it clear? So you are finished with front and back, right? Front and back. Now we'll go for right, left. So what is right? So you can see this right plane is perpendicular to y plane at a distance of b. So that means this equation will be y is equal to b, right? So what is this right? BEDC, right? BEDC. 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 And what about the left plane? So you can see this left plane. This left plane lies on XZ plane. Yes or no? Lies on XZ plane. That means what? Y is equal to 0. Y is equal to 0. So what is the left plane? O. This C is this C is small c, right? This C is the distance. Okay, good. Okay. Actually, here, sorry. Here everything is a distance of A, right? Sorry. So here everything is bounded by the same A, right? Sorry. So I used A, B, C. Sorry. This is all are bounded by A only, right? Therefore, this is also y is equal to A only. Sorry. The question they are given, everything is bounded by x is A, y is A, z is A. That means this is A, this is A, this is also A. So I thought it is A, B, C. So all are A only. So therefore, this is this plane is perpendicular to y-axis at a distance of a. So that means this equation is y is equal to a, and this lies on xz plane. So therefore y is equal to 0. Right? And what is the left plane? OGFA. 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 Now we'll go for top. So what is top here? This is the top, right? GFED. GFED. And you can see it is at a it is in a is perpendicular to z axis, right? Perpendicular to z axis at a distance of a. At a distance of a. So therefore, this is z is equal to a. Z is equal to a. And you see the bottom. So this is the bottom, right? This is the bottom. OABC, right? OABC. OABC. This lies on xy plane, right? This lies on xy plane. So therefore, z will be 0. Is it clear? See, these two columns will not going to change for any problem whenever you have cube. The only thing that you're going to change is here, suppose instead of a, if they give some numbers means you have to put that number instead of a. That's it, right? So you can see here this plane is perpendicular to y at a distance of a because it is bounded by y is equal to a. Suppose if they give some numbers like y is equal to 5 means this equation will be y is equal to 5. Clear? Okay. Now you need to find outward normal n cap, right? Outward normal n cap. Okay. Now let us come to the first. Now you can see this is front face, right? Front, back. This front, this back, this right, this left, and this is up and this is down, right? So there are 6 faces. Now for front face, this is a front face, right? So this front face, you have to find n cap. So n cap is the unit normal, right? You just see which is going out, right? We have 3 axes, right? We have 3 axes. So from here, x is going out, right? X is going out. So it will always be I vector, right? I vector is your unit normal for x, and for backward will be minus I vector. This will be j vector, and this will be minus j vector. This will be k vector. This will be minus k vector. This will be fixed, right? So just see for front face, you see which is living. So this is living x, and for back face, you can see this is which is living. So minus x is living, right? Minus x means what? It is minus I cap, minus I vector. And for this, you can see living is j. And for this side, this is the for right left hand side, the living is minus y, right? You just see which is going out, right? And in that direction. So, and for backward, you can see, sorry, for up, you can see this is z. Z is normal, right? Z is normal, unit normal. So unit normal is k vector, and for down it is minus k vector, right? This column will not change for any cube, right? This column will not change for any cube, right? The only thing that may change is x is equal to a, y is equal to a, z is equal to a, depending upon the bound that they are giving for cube. If the first 3 columns are clear, then you can do any problem that is based on cubes. These are very easy, right? F dot n ds. Right? Outward normal is n cap. Okay. Now we will find f dot n cap. So f dot n cap is very easy, right? So we know f. So if you make a dot product with I, so we will have x cube by z. Right? So what is f here? F is x cube minus yz I vector minus 2x square yj vector plus 2k vector, right? So you make a dot product with I. If you make a dot product with minus I, we will have minus x cube yz, and then you make a dot product with j, we will have minus 2x square y And if you make it product minus j, we will have plus 2x square y, and this will be 2, this will be minus 2, right? And you can also replace x to be equal to a, so we will have a cube minus y z, this will be minus of, sorry, here x is 0, right? Here x is 0, so it will be plus y z, it will be plus y z, and here y is a, so we will have minus 2x square a, and here y is 0, so this will be 0, and here is, okay, these two are constants, no problem. Now how to choose ds, right? Ds is also fixed for each cube, so x is equal to a, that means this will be dy dz divided by modulus of n cap dot dy dz, that will be n cap dot I vector, right? And similarly here also same, right? Dy dz divided by modulus of n cap dot I vector, and this is, we have y, so if we have y means you put dx dz, so if we have x means dy dz, here also x is equal to, that means dy dz, so here dx dz divided by modulus of n cap dot, what is missing here, y is missing, it will be n cap dot j, and here also dx dz divided by n cap dot j, and here z is equal to, that means dx dy divided by n cap dot k, right? This is the projection. So what is ds? It is the projection, right? So x is equal to a, that means it is on yz plane, right? So you can see this is on yz plane, so projection on yz plane, projection of yz plane, projection of xz plane, right? So 1, 2, 3, 4, so these 4 columns are fixed for every cube, whatever cube they are giving. Only thing that is going to change is this a will change, and depending upon the f dot n cap will change, right? Okay. Now what is n cap dot I? N cap is I dot I will be 1. This will be dy dz. And this will be n cap dot I. So here you have modulus here, so no problem. Again, we are going to have dy dz. This dx dz. Dx dy, right? So n cap is I, so I dot I is 1 minus I dot I. We have modulus here, so again it will be 1. N cap, yeah, sorry, it is n cap, right? It's not vector, it is n cap. Right? So n cap dot j. So that's it, right? So that means this column, this column, this column will not change for any cube. Now we need to evaluate each integral now, right? So what is S1? So S1 is double integral. We need to evaluate all 6 phases now. Double integral over S f vector dot n cap ds. So double integral over S. Now what is f vector dot n cap? So for S1, f dot n is a cube y z. A cube y z. And what is ds? ds is dy dz. And we know what are the bounds here. X varies from 0 to a, y varies from 0 to a, z varies from 0 to a. Right? So that's it. Now you need to integrate this to get S1. So integration of 0 to a with respect to y. So a cube y minus z into y square by 2, 0 to a dz. This will be integral 0 to a. So a power 4 minus a square z divided by 2 into dz, right? So just put upper and lower limit, that's it. A square by 2. Now with respect to z, so a power 4 integration of dz is z minus a square by 2 z square by 2 0 to a. So this will be a power 5 minus a power 4 by 4. So a power 5 minus a power 4 is the S1 now. Now again you find S2. S2 is double integral over S f vector dot n cap ds. And this x varies from here, everything is 0 to a, right? And what is f dot n for s2? It is yz. And what is ds? It is dy dz. So y varies from 0 to a, z varies from 0 to a. This will be integration of 0 to a with respect to y, right? So z y square by 2 0 to a dz. And I can take this a square by 2 outside. Integration of z is z square by 2 0 to a. This will be a power 4 by 4, right? A power 4 by 4. Y is it? Uh, with respect to y means we will have y square by 2, a square by 2, z square by 2. Is correct, right? We will have a power 4 by 4, right? F dot n cap is minus of x cube minus yz. So x cube is 0. So we'll have plus plus. Okay. Now similarly, you find s3 double integral over s f vector dot n cap ds. So what is f dot n for s3? It is minus 2x square a. And what is ds? ds is dx dz. And since x also varies from 0 to a, y also varies from 0 to a. So depending upon the x and z limits, you need to put here. But here, everything varies from 0 to a. So minus 2a is constant. X square dx is x cube by 3. 0 to a dz. So minus 2a is constant and this will be a cube by 3. Integration of dz is z. This is 0 to a. So minus 2a cube by 3 into a. It will be minus 2a power 5 divided by 3. This is our s3. Now you need to find s4. So s4 is double integral over s f vector dot n cap ds. So what is f dot n cap for s4? So it is 0, right? So 0 into ds is dx dz. This will be 0, right? This will be 0 because 0 and everything is 0. Now we will find s5. S5 is double integral over s f vector dot n cap ds. F vector dot n cap is 2 and ds is dx dy. And we know x varies from 0 to a, y also varies from 0 to a. So 2 is constant. So integration of dx is x varies from 0 to a into dy. So we will have this to be 2a square, right? Um, um, 2a square, right? This will be 0 to a. So 2a integral dy 0 to a. So it will be 2a square. And similarly, you find s6 double integral over s f vector dot n cap ds. So minus 2 dx dy. So 0 to a, 0 to a, you will have minus 2a square, right? That's it. So therefore, double integral over s f vector dot n cap ds is equal to double integral over s1, double integral over s2, double integral over s3, double integral over s4, s5, and s6, right? You need to put f dot n cap, but I'm not using this. What is s1? S1 is a power 5 minus a power 4 by 4. What is s2? S2 is a power 4 by 4. S3. S3 is minus 2 a power 5 by 3. And s4 is 0. S5 is 2a square and this is minus 2a square. These two will get cancelled. These two will get cancelled. So we will have a power 5 minus 2 a power 5 by 3. So 3a power 5 minus 2 a power 5 by 3. So this will be 3 a power 5 by 3. A power 5 is it? Sorry, yes, 3 minus 2 is 1, right? So it will be a power 5 by 3. and a power 5 by 3. Is it clear? So a power 5 by 3 is the required answer. So you just remember the first column, 1, 2, 3. There are 4 columns, right? The first 3 column and the last column will not change, but this column, this A bounds for x is equal to A, y is equal to z is equal to A. That will change depending upon the question. But this column is fixed. This column is fixed for any cube. This column is also fixed for any cube. You just find the, depending upon the bound, you just find these equations and you just find f dot n cap, that you can do very easily, and evaluate each integral and add it up to get the overall answer. So we'll do one more problem of surface. Actually, we're going to do lots of problem surface integral. That when we are doing divergence theorem, Stokes theorem, there also we're going to evaluate surface integral only, right? So we're going to do many problems. So don't think the surface integral is stopped, right? There also we're going to have surface integral there also. That you will know very quickly. We'll do one more problem and then we'll wind off this topic. Sixth problem. I'll give only hint. You do the problem, right? Sixth problem is to evaluate if f is two y I vector minus bj vector x square k vector and S is the surface of the parabolic cylinder. Parabolic cylinder. Cylinder y square is equal to 8x. In the first octant, bounded by the planes y is equal to 4 and z is equal to 6. Evaluate double integral over s f vector dot n cap ds. Right? Very easy problem. So from the question, I have already said, right, from the question itself you can easily find ds. So you can see we know the bounds for y and z. Why? Because we know it is in first octant, so therefore y varies from 0 to 4, z varies from 0 to 6, right? So what I'm going to do is I'm going to directly write down the formula for double integral over s f vector dot n cap ds. This is double integral over r f vector dot n cap. I'm going to choose ds to be dy dz divided by n cap dot I, right? So we know the bounds for y and z, right? So therefore, you can easily write this to be equal to z varies from 0 to 6, y varies from 0 to 4, right? From here, because it is in first octant, f dot n cap, f vector dot n cap into dy dz divided by n cap dot I vector. So we need to find f vector dot n cap, and then this we need to integrate. That's it. Okay. Now, what is phi here? What is surface? It is 8x minus y square, right? Or y square minus 8x. So that means what is n cap? So n cap is del phi divided by modulus of del p. So del phi will be dou phi by dou x I vector, dou phi by dou y j vector, dou phi by dou z k vector, divided by modulus of del phi. So what is dou phi by dou x? So it is 8I vector, dou phi by dou y. So it will be minus 2y j vector, right? Minus 2y j vector divided by, so what is modulus of del phi? It is 64 minus 4y square. And this will be 8I vector minus 2yj vector divided by, so we take this 4 outside, we take 4 outside, 16 minus y square, and if I take this 4 common here, we'll have 2y, sorry, I take 2 out common here, 4I minus yj vector, and if I take this 4 outside, we will have 2 times root of 16 minus y square, right? So this will be okay, sorry, plus, right? Sorry. So 4i minus yj divided by root of 16 plus y square is our n cap, right? This is our n cap. Now what about f vector? What about f vector dot n cap? So f vector is 2y I vector minus 3j vector plus x square k vector dot, what is n cap? So n cap is 4i vector minus yj vector divided by root of 16 plus y square. So make a dot product with I. So we will have 8y minus plus 3y, right? 2y into 8 will be 8y plus 3y divided by root of 16 plus y square, right? 16 plus y square. So this will be 11y divided by root of 16 plus y square. And what about n cap dot I? Okay, I'll do this separately. So we will have double integral over s f vector dot n cap ds is double integral over s f vector dot n cap ds is now what is f vector dot n cap? We have already found, which is now what is n cap dot I? So if you make a dot with I, n cap dot I will be 4 divided by root of 16 plus y square, right? Make it up with I, we'll have 4 divided by root of 16 plus y square. This 2 will get cancelled. So this will be 11 by 4. So z varies from 0 to 6. Y varies from 0 to 4. 11 by 4 I taken outside. So y into dy dz. Right? Now I think you can easily do this, right? So integration of 11 by 4 y dz. So the answer you're going to get is 132 will be the answer, right? Very easy to perform, right? It will be y square by 2. Put upper and lower limit, and we evaluate dz and then integrate with respect to z. So overall, you're going to have 132 as your answer, right? So I'm going to do only one problem on volume integral. So I'm going to do only one problem on volume integral. Suppose B is a volume. Suppose B is a volume bounded by the surface S. bounded by the surface S. If f of x comma y comma z, f of x comma y comma z, the vector point function, then the volume integral is given by, then the volume integral, then the volume integral is given by triple integral over v f dv, right? F dv, or this can also be written as f of x comma y comma z dx dy dz. Right? So dv is dx dy dz. This is a normal f dv, right? It is not dot product. So f of x comma y comma z into dx dy dz, right? Okay. So we'll do the problem now. Yes. Evaluate triple integral over v p dv, right? So instead of f dv, they can p dv, where p is, this is very easy, right? Volume integral is very easy. P is 45 x square y, and v is the closed region bounded by the plane. See, in surface integral, we will only find these, right? We will only find this, but for volume, we will find all the volumes inside this also, right? And B is the closed region bounded by the planes 4x plus 2y plus z is equal to 8, is equal to 0, y is equal to 0, z is equal to 0, right? So we need to evaluate in the triple integral over s p dot dv, and p is 45 x square y, right? It is 45 x square y. See, here we have written this is same as r, can also written as triple integral over v is f dot dv, right? Dot only, sorry, f dot dv dot product, or it can also written as function of xyz into dx dy dz, right? So they have given function of xyz, and now we need to I'll do this directly, right? Solution. So we know this is triple integral over v p dv is same as triple integral over v p of x comma y comma z dx dy dz, right? Dx dy dz. Now only thing is we need to find the limits for xyz. The limits for xyz is 45 x square y dx dy dz or dz dy dx, right? You can integrate in any order, right? You can integrate in any order, or you can also use dz dy dx, right? That is your wish. Okay. Now see, here they are given some plane, right? It is bounded by x is equal to 0, bounded by these two planes. Okay, let us draw some very rough diagram, right, to give you clarity. So we have a plane, right? We have a plane. We have a plane. We have a plane like this, right? We have a plane like this. This is, let us say this is 2, this is 4x plus 2y plus z is equal to 8. And this x is equal to 0, y is equal to 0, z is equal to 0. Now, for volume integral, we need to find all these, right? But for surface, what we will do? We will only find this, the outer region, right? The outer region. But here it is volume. So what we will do is, let's say this is x, right? Let's say this is x-axis, this is y, and this is z. Now, here you need to keep one as constant, that is among these three axes you take one as constants, that is 0 to something, right? Other two as variable, then only you can cover all this, right? I repeat. So to find limits, see here this what is the plane here? It is 4x plus 2y plus z is equal to 8, right? Let us find x in terms of number. That means we already know this x is 0. To find this, you put y to be equal to 0, z is equal to 0. So if y is 0, z is 0. What about x? So it is 4x plus 2 into 0 plus 0 is equal to 8. This means x is equal to 2. That means x varies from 0 to 2, right? Because it starts with 0. So x varies from 0 to 2. Now you need to treat y as a variable as well as z as a variable now. Then only you can cover this entire region. If you treat y as a number means you can only cover this region alone, but you need to cover the entire, you need to visualize in 3D, right? Okay. Now we have found y x limits, right? Now for y limits, this is for x limits. Now for y limits, you put z is equal to 0, right? For x limits, we have put y is 0, z is 0. Now for x limits, you put z is equal to 0. So we will have 4x plus 2y is equal to 8. That means 2y is equal to 8 minus 4x. That means y will be 4 minus 2x. That means y varies from 0 to 4 minus 2x. 0 to 4 minus 2x, right? So from this limits, we can cover this y parts. Now we need to go for z, right? So for z limits, you bring all the terms this side. So 8 minus 4x minus 2y. So z varies from 0 to 8 minus 4x minus 2y. That's it. See, you can also treat y to be some number, right? That means you can put x is 0, z is 0. Then you can also treat y to be from 0 to some number. Now you can treat x and z to be a variable. So if you use this limit only, you can cover this inner region also. So to cover this inner region, you treat one as number to number. Number to number means what I'm saying is 0 to 2. But here these two are number to variable, right? So here number to number. So I'm taking x to be number to number. You can also take y to be from number to number. That means you need to put x is 0, z is 0. Right? You can use anything. These are the limits. So if you use these limits, mean you can cover the inside region also. Right? Therefore, what is dz? So first we need to start with x. X varies from 0 to 2. Y varies from 0 to 4 minus 2x. This is the idea, right? To find x limits, you put y and z 0. To put y limits, you put z 0. Now for z limits, you don't put anything to be 0, right? You just take all of the terms that side. Z varies from 0 to 8 minus 4x minus 2y into 45 x square y dz dy dx. That's it, right? Now you can easily integrate this, right? This will be x varies from 0 to 2, y varies from 0 to 4 minus 2x. With respect to z, that means 45 x square y is constant. So integration of z is z. So 0 to 8 minus 4x minus 2y dy dz. So this will be 0 to 2, 0 to 4 minus 2x. So upper limit will be 45x square y into 8 minus 4x minus 2y dy dz. This will be 0 to 2. So 0 to 4 minus 2x. So if you multiply this inside, so 45 into 8. 45 into 8 will be 8 5s are 40, 32, 360. So it will be 360 x square y. 45 into 4 will be 180, right? So minus 180 x cube y minus 180. I think I can take this 45 outside, right? Take time. Let's take this 45 outside. So just multiply only x square y. So we will have 8x square y minus 4 minus 4x cube y, right? Minus 4x cube y, and here minus 2x square y square dy dz. 45 x varies from 0 to 2, y varies from 0 to 2 with respect to y. So 8x square is constant, and this will be y square by 2. 4x cube is constant, will be y square by 2. 2x square is constant, this will be y cube by 3. The upper limit minus lower limit. So 0 to 4 minus 2x dz, right? dx. Right now you can easily integrate this, right? So you just put upper limit, expand it, you'll get the answer, right? See, actually we have only did one problem, volume integral, right? So don't worry. The next class we're going to start Gauss divergence theorem that tells the relationship between volume integral and surface integral. There we will solve lots of problems based on volume integral there also, right? As of now, you just follow the lecture. From the next class onwards, you can you can do in your own, right? So after finishing Gauss theorem, Stokes theorem, and Green's theorem, that if you know how to perform these three, then those three theorems are just the relation between surface, volume, and line. That tells the relation between surface, volume, and line. Those three theorems. As of now, you study up to only this. So you just evaluate this. The answer will be you get 81 is the answer. Fine. 81. 128 will be the answer. Right? 128 will be the answer. Okay, so we have finished this topic. So we will be having the test on line integral, surface integral, volume integral very soon. From the next class, we will start Gauss divergence theorem in the next class, right? Just practice some problems based on line integral, surface integral, volume integral. The three theorem that we're going to see from the next class will be very easy if you know how to evaluate line integral, surface integral, volume integral, right? Okay. Next class we will start Gauss divergence theorem, right? Thank you, bye.